we're going to look at exam technique in this video with questions that look like the one below. So we've got our function, it's a cubic here, and it says show that there is at least one root in the interval of 1 to 2. So when we see something like this, what we've got to do is we've got to evaluate f of 1, evaluate f of 2, and then there is a precise conclusion that we need to say, which will give us typically 2 marks. So this one's not too bad, but sometimes the question will be quite long, so you might want to use the table mode on your calculator. Then what you do is you sort of go through something like this and you type in the function that you've got in front of you. So x cubed plus x minus 5 equals, it says g of x on my next screen, so I just press sort of equals again. I'm going to start at 1 and finish at 2, going up in steps of 1. That should give me the answers I need. So f of 1 is going to be, well, you know, I'll just quickly sort of write that one out. It's going to be minus 3. Okay, so that's with 1 substituted in. Okay, and for the other one, with 2 substituted in, is going to give me an answer of 5. The conclusion then, there has been a sign change and the function is continuous. Therefore, there is a root in the interval 1, 2. Okay, so that's what a model answer would look like. Yeah, sign change we want to hear, continuous we want to hear as well, because if you don't have a continuous function, your conclusion doesn't actually hold true. We also want it backed up by the numbers, and if we've done it correctly, the numbers should be different for each. So for the next part, starting at 2, we're going to use the Newton-Raphson method to find a better sort of approximation of the root rather than 2. So we want our formula first. Our formula is that our next approximation is equal to our approximation before, take away the function evaluated at our approximation over its derivative at that approximation. So let's put some numbers in for our situation now. So for us, our x1 is going to be equal to our x0, which is 2. Take away our function evaluated at 2. So if we just did this, it's a bit risky because Edexcel often asks for a changed function. So a changed function means when you write sort of what it is, you know, x cubed, blah, 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 with 2 clearly substituted into it. So it should look like this, but with a 2 inside. Okay, it's derivative, so sometimes you can have some hard differentiation on this one here. This one's not too bad though. F of x is going to be equal to 3x squared plus 1. Okay, so we're going to do 3 something squared plus 1, and it's that same number again is the idea. So this would be sort of the working out that we are looking for. This question here, you know, I've generated this question, but they'll often ask you to give this to say 2 or 3 decimal places, something like that. Anyway, let's just work this one out. So plus 2 minus 5, 3 brackets 2 squared plus 1. Okay, so I get 21 over 13, which is equal to 1.615. So I'll go with 3 decimal places. So that's how we would perform the method. A couple of things to pay attention to for the exam technique then. Clearly evaluating at the number, a conclusion about a sign change and it's continuous. for the Newton-Raphson, making sure I'm quoting the right formula, and I'm substituting in, and when I substitute in, I have a changed function. If you just said f of 2 and then you have the wrong answer, you open yourself up there to dropping quite a lot of marks. Let's do an example with something that's a little bit trickier. So this is a trig one this time. So we're showing, it's called g of x. We're showing that g of x has an interval, a root in the interval 0 to pi over 4. So we need to be in radians mode. And we're going to start by doing g of 0 and g of pi over 4. So this is going to be sine of 0. This is going to be sine of 2 times pi over 4, pi over 2, minus 0.5, minus 0.5, and we're going to work these out. Now, sine of 0 is just 0, so that's minus 0.5. Now, what would we be expecting here? Well, our conclusion is about a sign change. So, yeah, I get 0.5. I mean, probably could have done that one without a calculator, really. But there we go. We can see that there is a sign change. So what was our conclusion? There has been a sign change and the function is continuous. Therefore, there is a root. Okay, so there has been a sign change. There has been a sign change. And the function, well, actually, the function is always continuous, isn't it, for sine? And the function is continuous. So if you want a slightly different version, so you can call it alpha or the root. The root is between, what were our numbers? 0 and pi over 4. Okay, really doesn't take that long to say. So when you know what you're doing, it's an easy 2 marks. The Newton-Raphson. So here we go, Newton-Raphson. Our next guess is the previous one. Take away what? What's in the numerator? The function with our sort of previous one in it, divided by the function differentiated, evaluated at that number. So x1 will be equal to what? It will be 0.5 minus, so let's leave ourselves some space here. So we're writing it as a changed function. So 2 times 0.5 minus 0.5. Okay, differentiated. So how to differentiate sine of 2x minus 0.5? Well, the 0.5 will differentiate away. And here, this is a chain rule, so it's 2, and then sine goes to cos, so it should be 2 cos 2x, okay? So let's do all of that. It is 2 cos 2x, so 2 times 0.5. Very easy to make a mistake on those bits there. Now we just need to make sure that we're in radians mode on our calculators. And we need to just type it in. So that's sine 1, 2 cos 1. Okay, there we go. So I get for x1 0.184 to 3 decimal places. Okay, I suppose we could carry on doing it, but a lot of questions just ask you to do the Newton-Raphson method one time, and that's how you would have a go at doing it.